All right. We are looking at properties of logarithms today. So properties of logs. So answer this question for me. Logarithms are blank. Exponents. That's what you got to keep in the forefront of your mind. And so because a logarithm is an exponent, if you'll think of exponent rules or laws, then you should be able to come up with the laws for the logarithms. So, products. We're doing products. So here would be the analogy. Let's see, let me do it over here to the right. We all know this rule. We've had it ad nauseum. X to the a times x to the b equals x to the... Beautiful. All right, so we are multiplying like bases, and we all know that x to the a times x to the b equals x to the a plus b. Therefore, the log of xy in base b must be... Anybody want to take a stab at it? Because logarithms are exponents. Luke? It is the log of x in base b plus the log of y in base b. Because logarithms are exponents. So what's the analogy? And you don't need to mark this in your notes, but logarithms are exponents, right? And you add the exponents. That is an exponent, and that is an exponent, right? Logarithms are exponents. And you add the exponents. That's the tie-in. All right, so the properties allow you to do some things within mostly logarithmic equations, and that's the end of the chapter. So right now we got to do some other creative things to get you to learn the properties so that later on when we do equations, you can apply the properties and solve the equations. So again, the kind of stuff we'll do right now is really just something to get you to learn the rules and the properties. And the real purpose is later on in equations. So, for example, if you had log of 14 in base 2, then you could obviously split this thing up. And by the way, log of 1 is real boring, so we don't usually use ones. But hopefully you agree that we could make this log of 7 in base 2 plus the log of 2 in base 2. And I could have did the order the other way, right? Log of 2 in base 2 plus log of 7 in base 7, commutative property. Okay, let me help you out. 14 is 7 times 2. Okay. So I did the log of 7 base 2 plus the log of 2 base 2, because 14 is 7 times 2. And the 7 is like the x, and the 2 is like the y. Is that okay? So you have a product situation. This one is more valuable in that if you were solving a logarithmic equation with something like b, and you're trying to isolate the variable, it helps to be able to split it up, right? So this could be log 3 in base 5 plus log x in base 5. And we're rapidly getting to the point where we can get this value right here. I mean, that's just a number. And again, if you're thinking logarithms, that's 5 to what power equals 3? So something a little less than 1. Okay, but we're able to split it up. So again, we're just doing stuff right now to get us used to the law. So in this third one, now they gave you values, and they said the log of 10 in base 7 is 1.1833, and the log of 50 in base 7, or they said the log of 5 in base 7 is also 0.8271. Find the log of 50 in base 7. So if you use the property, right, hopefully you're thinking then, okay, This is the log of 5 in base 7 plus the log of 10 in base 7. Right? A 50 is a 5 times 10. And now it's just substitution. All right, so this is what the value of that one is. And 1.1833 is the value of the other. And we can just add those up wherever you end up. Use your calculator. Looks like it's 2 point something, right? Anybody add that up? What is it? What do you got, Destiny? 2.0104. All right, 2.0104. Question-wise?
Can we put as the exponents 25 times 2 instead of 5?
You could. I mean, there's a lot of different ways you can split it up. However, because of what they gave you, so if you went 25 and 2, you would be able to go no further. You wouldn't be able to get a final answer. But they gave what the log of 5 in base 7 is. It's this value. And they gave what the log of 10 in base 7 is. It's this value. And because they gave you those values, you'd much rather want to use 5 and 10 for this specific situation, because those are the values they gave you. Okay. What if they gave you, instead of this one, what if they gave you log 2 base 7 and they gave you some value? How would you do the problem then to figure out the log 50 in base 7? Then you would do, Hunter?
You would have log of 2 base 7, log of 5 base 7, and another log of 5 base 7.
Yeah, because, right, 5 times 5 times 2 is 50. So again, you could do log 5 base 7 plus log 5 base 7. That's the 25 plus log 2 base 7, and that's the 2, and get all 50, right? Can do 3, right? 4. It's still the same principles and as many multipliers, right? You're simply adding that log. All right, so let me get that out of the way so things are clearer. All right, so yeah, you can. There's a lot of different ways you can split it up, but you definitely want to go the way that's going to allow you to accomplish what it is you're trying to accomplish. And all right, it's being very rebellious, so that's okay. All right, excuse me. So that's the first one. Let me get rid of my shade so I can go higher here. So here's the second one, the quotient law, and my fraction's a little lower than I wanted it to be in that parentheses. It really should be higher, right? That fraction, when I went to print or when I moved something, it stayed and I didn't move the fraction. So that should be higher. Not a big deal. All right, so knowing that logarithms are exponents, how would this law come out? Give me this law. Give me this law. Destiny?
Log dx.
In base B, okay?
Minus log y
I wouldn't write anything yet. Log of
y.
in base B. All right, so Destiny says log of x in base B minus log of y in base B. Anybody agree with Destiny? Nobody agrees with you. Actually, one late hand came in because nobody believes that x to the a minus x to the b equals x to the a minus b, I guess. Nobody believes that. And logarithms are exponents. And again, this is an exponent, and this is an exponent. So they should have believed you, but they didn't. So now you can write it because that is what it is. Log x base b minus log y base b. When you have a fraction for the number there, then you can do subtraction. And again, it just goes with the exponent rules. So this first example here would be log 5 in base 3 minus log A in base 3. Right? Because again, the log 5 base 3 is an exponent. The log A in base 3 is an exponent. And we're subtracting the exponents. You can get creative in that second example. Right? We can get creative in the second example. And would you agree that this would be, how about 7? Whoops, got my 7 in the wrong place. How about log 7 base 7 plus log n base 7? Say, Mr. Scarfi, what are you doing? We're doing subtraction. Oh, I'm just doing the numerator right now. I kind of split up the numerator, first law we did, and now I'll do the denominator, minus log 11 base 7. So I just completely split it up as much as I could, because the numerator had two things multiplied and then minus the denominator. Do you need a parentheses here? Is that needed? Parentheses? It's just addition, so it doesn't really matter. It's not a big deal. Now, if I had a product in the denominator, okay, this isn't what's there, but let's say, don't write this, let's say the denominator was a 22, and then I did this, right? And I did that. Let me go higher for you. Do I now need a parentheses there? Yeah, then I would need a parentheses, right? Because it's minus the whole denominator, which is that, all right? It wasn't what was there, but if it was, that's what you would have to do, okay? Any questions on those first two laws? They come up occasionally, come up here and there. This next one comes up all the time. This one is like the key of all of them. You use this the most. It's the hostess with the mostest. All right, you use it the most. Comes up all the time, and this one you got to have down. All right, so it's the power law. Anybody want to go for the power law? How do we end up with the power law? Come on, be brave. You can't get the glory if you don't have any guts. No, I'd just rather be a sheep and just be there quiet. Luke, what do you think? Don't write anything yet, by the way. Go ahead. So log of x in base AB, like that? Anybody agree? Your brother's with you. A few others? All right, well, that one's wrong. But good try. You guys know about Milton Snavely, right? Wanted to open up a candy factory, opened it up and failed. I think it was in Chicago at the time. It failed. Went to St. Louis. It failed. Went to New York. It failed. Like failed a few more times. Milton Snavely just couldn't get it going. Finally returned home to Pennsylvania and decided to try just chocolate instead of all different candies. And the rest is history, right? You know who the guy is? Hershey, right? And but he failed and failed and failed and failed and failed and failed, and then finally hit success big time. Anybody else want to give this one a try? Alex?
A times the log of x in base b.
Again, don't write anything yet. A times the log of x in base b. Anybody with Alex? Just go with Alex because it's Alex? A few of you go with Alex because it's Alex. Can anybody explain why Alex is correct? Destiny?
Because it's being put to the power, so the power would be actually multiplying times the...
Okay, she said the log is being put to the power, so the power will actually be multiplied. Does that help anybody?
It works the
It does work in Destiny's mind. And Destiny does understand because she got the second one. You know, perhaps if we use this rule, we would definitely come up with x to the a times b, or b times a. And again, logarithms are exponents. What happens to the exponents? They get multiplied. They get multiplied, right? The a times the log of x in base b is multiplication. And so that is the power law. And this one gets used all the time. So the exponent comes out as a multiplier. The exponent comes out as a multiplier. So the first one, a, is pretty simplistic. You can put a 2 out front, right? 2 times the log of n in base 7. What are you going to do with b? Now we got to apply things that we've learned involving roots and radicals, and now apply also the power law, and we can deal with b. So what does b end up? What does b end up being? Come on, what does b end up being? Come on, people! Try something. Think. Here, I'll give you one hint. Change the form of this first. Okay, change the form of that. Marissa, what do you want to go for?
1/3 log x base a.
So Marissa says 1/3 log x base a. Anybody with Marissa? Should be all of you, right? Good job, Marissa, right? Because a cube root is something to the 1/3 power, isn't it? Isn't the cube root x to the 1/3? And therefore, doesn't the 1/3 come out in front as a multiplier, right? So again, for those of you that don't see it, that's an x to the 1/3. And the 1/3 comes out as a multiplier. Okay? All right. Something like C. Sometimes you can get a little creative and go past just standard stuff here. What if, because I'm seeing this 3 and that 27, what if instead I made that 27 a 3 cubed to the 5th? Right, same thing. Do you agree? So now, without doing every little step, and now doing the power law, what would be next? Come on, what's next? Use the power law. What's next? Say it again. Okay, so tell me what to write. Okay, that's what I was after here. Let me use my red. So it would be a 15, right? Because you're going to multiply 3 times 5 and get 15 log 3 in base 3. And by the way, what is the log of 3 in base 3? It is 1, right? So this is 15, right? Again, we still haven't gotten to the point where we're using our calculator for things like that. We'll get there real soon. But again, because you know that that's 3 to what power equals 3, right? Change it to exponent form. Therefore, it's 3 to the first power equals 3, and the answer is 1. Because again, that green box is a exponent. And what is the exponent? 1. 15 times 1 is 15. And you can then get that all the way down to there using the power law and what you understand about logarithms. Okay, so let's do a little bit more of that kind of concept here. Let's use the log laws to simplify these. Okay, so what I want you to do in A is go as far as you can. Split it up and simplify it as much as is possible. All right, and I'm going to pause and give you time to do that if I can find where in the world my recorder went. Where are you, recorder? No idea. Am I even recording? Yeah, there we are. So you got log 2 in base 8 plus 3 times log n in base 8 minus log 5 in base 8. How many had that correct? That exponent you can't put out in front until you get it just to where it's isolated, right? So if you try to bring out that 3 out front too soon, you're going to have it in the wrong place, at least in this situation. And again, it goes with the aspect of an exponent only goes to its base, right? If you misappropriate the exponent, then you're going to mess up with the multiplier. Any questions on that one? Okay, so try B now. See what you can do with B. Again, I'm going to pause. So 1/7 times log of 5 in base 2 plus 2/7 log x in base 2. And I just tried to show you the steps. First I did the 1/7 for the radical. Then I applied the regular exponent law. X to the a times x to the b equals x to the a plus b. 5 to the 1/7, x to the 2/7. Then I did the product law, and then I did the power law. Right? Any questions in that one? Anybody? How many got that? Okay. So again, what we know about radicals, 1/7. What we know about exponents, distribute to 1/7. What we know about products, what we know about the power law. So you got to put it all together. Okay. Number 5, simplify into a single. So now let's go the other way. Let's go backwards the other way. What's key? The bases have to be the same here, right? I mean, you can't do this if the bases weren't the same. And by the way, don't miss that on all of these. It's the bases are the same, and therefore we're able to do what we're doing because you have like bases. Okay, so you got a couple things here. I don't know what order you want to go, but I immediately see to do this, right? Undo the power law on the front one. And now I'm looking at this minus. So I got log base 3, and I know my numerator is x squared. And my denominator is 4x. All right? Because of that parentheses and the log 4 base 3 plus log x base 3. Does that make sense? So I undid, went backwards the other way, made it a single logarithm. Any questions on that? And again, you just got to know the properties to be able to do that. If you don't know the properties, then you're not going to have the thoughts of what to do. So work on the properties, get those down, make sure you have them down pat. Okay, we kind of used this property already, and it's a property of equality of logarithms. If log x in base b equals log y in base b, then what can we claim? Well, if you'll just change the form into exponent form, I think it'll be real obvious. Like the front one is b to what power equals x, right? And the second one is b to what power equals y. Maybe that's not so clear. Maybe that doesn't help you because instead of it being yeah, I don't know that that's going to help you because of the difference there. Let me just give it to you then, and maybe that'll be easier for you to understand. All this thing ends up is the x has to equal a y. the x has to equal y. I'm going to get rid of that because I don't think that helps. Didn't help me. I don't know if it helped you. Didn't give me any clarity. Not going to give you any either. There is a condition on this. The b's got to be not equal to 1, and the x has to be positive. And so just one of the conditions of it. Okay, so what do we do with that? Let's see if we can then do a little bit with that. So here's that same scenario. So first off, would you agree I need to fool with the power law and get that up top? Here, let me go higher for you guys. Okay, so this is what I'm after. These two matching, right? And when they do, then these two are equal, right? That's what I'm after. So if I use the power law, let's see, now I have these two matching. Do you agree? And therefore then I have 5 squared equals n minus 4. And I can solve that. And so what do we got? A 25 plus 4 is a 29 equals n. And we just solve that thing. So one more time, what is this equality property trying to tell us? If you have the logarithm, x in base b equaling the logarithm of y in base b, then the x equals the y. I put it in that condition, and therefore then I was able to say 5 squared equals n minus 4, and I was able to finish it off. Okay? Why don't you try the last one? Try the last one. Right, as soon as you did the power law and moved that 2, you ended up with a quadratic, right? You end up with 49 equals the quantity of x plus 1 quantity squared. And now you're ready to take the square root of both sides, right? Because the squared quantity is isolated. And we certainly didn't forget the plus minus, did we? By the way, you could also do it another way, but this is the quickest way. And remember, one time you got to use the plus 7 equals x plus 1. Move the 1, 6 equals x. Then you got to use the minus 7 equals x plus 1. Move the 1, negative 8 equals x. How many got it correct? Oh, 0. All right, well, now you know. Now you know. It's just quadratics. We've done quadratics. And that was an easy quadratic. All right, be careful. Learn the properties today. I will definitely ask you the properties tomorrow on the quiz. No doubt about it. No, I mean, hands down, I'm going to ask you the properties. Hey, make sure you can take common logs tomorrow. Make sure you can convert between exponent form and log form easily both ways. You got to be able to do that. So things we've done for 8.5 and then today's 8.6 quiz tomorrow.